Adding and subtracting square roots. Whenever we add two terms together, they have to be alike, meaning they have to have the same structure. Looking at example A, we have two square roots in our problem that we're trying to add together. One is a square root 5 and the other is a square root 20. So we want to try to change them so that they match, so that they are like terms. Let's do a little bit of work on the side before we start this problem. Looking at the square root of 20, we know that 20 is 4 times 5. And the product rule for square roots tells us that we can split this into two square roots that are being multiplied together, and then I can simplify the square root of 4 to be 2. So instead of writing square root of 20 in my problem, I'm going to substitute 2 times the square root of 5 in here. So let's start our problem now. Square root 5 plus 6. Instead of writing square root 20, I'm going to write 2 square root 5. I'll multiply the 6 times the 2 to get 12 square root 5. And now I've got like terms. It's not written, but there's technically a 1 in front here. So I'm adding 1 plus 12, and I have 13 square root. Example B. I've got two different square roots that are not similar, so I want to try to simplify them and see if I can make them like terms. Let's look at the square root of 44z first. 44 is 4 times 11. I can bring that square root of 4 out, separate those, because 4 is a perfect square. So I end up with 2 times the square root of 11z. I can do something similar for the square root of 99z. That's 9 times 11z. And then if I separate the 9, I get 3 times the square root of 11z. I'll take this first square root and substitute it in for the 44z in my original. And I'll take the 3 times square root of 11z and substitute it in here. So rewriting my problem, I've got 3 times 2 times the square root of 11z plus 3 times the square root of 11z. This is 6 plus 3, and we have like terms now. We can see that these two items are identical, so we can add the 6 and the 3. And we end up with 9 times the square root of 11z. Moving on to example 7, we're going to follow the same strategies. The first two problems were addition. Now we're going to look at some subtraction. Let's think about the square roots and how we might be able to simplify them before we start this problem. Let's see. The square root of 80x. Well, 80 is 16 times 5. I'm trying to think of any numbers that are perfect squares that I can bring out to the front so I can simplify. And the square root of 16 is 4, so that makes that easy for us to simplify. Looking at the square root of 45x, (45) is 9 times 5. So I can separate that square root of 9 and get 3. This is looking good because these two square roots that I'm ending up with both are the same, and it looks like I'm going to have like terms. So this is going to get substituted for this, and this will get substituted for this. So rewriting my problem, I'm going to have 3 times 4 times the square root of 5x minus 4 times 3 times the square root of 5x. This is 12 times the square root of 5x minus 12 times the square root of 5x. This was a tricky problem. Those two original terms that we had were actually identical, and we're ending up with 0 as our final answer. Let's move on to example B. I'm going to do some side work here to try to simplify these square roots. B squared is a perfect square, so if I separate that out, I can say that that's just b times the square root of a. And the second square root can't be simplified at all. So I'm going to substitute this for this. We have 3 times b times the square root of a minus b times the square root of a. I have 3 b's and 1 b that's being subtracted, and the square root of a's match, those terms match. So 3b minus b is 2b times the square root of a.